Okay, so I want to continue on this week with the ellipse, so a little bit of revision. Now, this week I want to look at drawing a tangent and a normal to the ellipse, okay? So it's on page 113 in your books, and I'm just going to go through exactly here how it's done and just a little bit of revision on what actually a tangent is, okay? Now, so first of all, what is a tangent? Okay, so here a tangent is a line that touches a curved surface at one point only. Okay, now so we see here in our ellipse example here, the tangent line is this line here. Okay, now the tangent only touches the ellipse at one point, and that particular point, it's point P. Okay, now just to bring it back to the basics, to a circle. Okay, so here I have a circle. And the same principle applies to a circle or any curved surface, okay? A tangent line is only going to touch the ellipse at one point only. So, for example, I'll just take this ellipse or this circle here now, okay? If I want to find a tangent to this, okay, I'm going to, if I have the center point, okay, I'll draw a line. Now, this line I'm after drawing here is known as my tangent, okay? It's only touching the ellipse at one point only, and that's that point there. What's very important to also know is the line that's at 90 degrees, okay, or is perpendicular to the tangent at the point at which it touches the curved surface. So the point at which it touches the curved surface, so it's going to be this point here, is known as the point of contact, okay? So a line that goes at 90 degrees or perpendicular to the tangent from the point of contact is known as the normal, okay? As the normal, okay? So if I want to find, for this particular circle, if I want to find a tangent at any point, okay, I'm going to draw, I know that the normal is 90 degrees to the eel, or to the tangent. So for example, if I want to draw a tangent from this point here on my circle, okay, I'm going to join the center point to that point, okay? So now I know that this here is my normal. I know that my normal is at 90 degrees to my tangent, so I'll just go ahead and I'll draw a line that's 90 degrees to that normal from that point. Okay, and that gives me this line here as my tangent line. Okay, it's only touching the circle at one point only. Okay, now that principle works with no matter whereabouts it is. So just here, have I got it? Okay, so here is example here. Okay, so here's my circle. This line here is my tangent because I know it touched the ellipse at one, or the circle at one point only, which is this point here. And I know this here is my normal because it's at 90 degrees to my tangent. Okay, no matter whereabouts I move that tangent around, okay, it's the same principle. Okay, if I leave it here, the normal is still at 90 degrees to the tangent. If I bring it down to the bottom, okay, it's at 90 degrees to the tangent. Okay, and the same principle applies the whole way around for that. Okay, so now we know that a tangent is a line that touches the curve at one point only. So how do we bring this into principle with our ellipses? Okay. Now, so this is I'm just going to draw this example here for the ellipse. I'm going to actually just draw it out just to show you again if anyone's confused on how to draw the ellipse. So I have my major axis here, and I have my minor axis. Okay, to draw the ellipse, we know from the major axis we have to draw in what's known as the major circle, and the minor axis we're going to draw in the minor circle. Okay. Now, so this is from last week. Everyone should know how to do this still. We're going to divide it up into 12 parts using the 30-60 set square. Okay, each of these points passing through the center of my circle. Okay, stand that one up as well. Now, okay. Sorry now. Okay, now to construct the ellipse, then we're coming down at all our different points. So I want to Okay, so that's the construction for my ellipse. Okay, I know all these points are points of my curve, so I'm going to draw in again. This should be done freehand and try use smooth lines, not going over it, not going over the same line multiple times. Okay, so there we go. Now I want to construct a tangent to the ellipse. Okay, now there's two different ways we can do this. We can be asked to construct a tangent from the ellipse from a point on the curve or a point outside the curve. Okay, so for the example we're doing today, we're looking at drawing a tangent to an ellipse at a point P, which is on the curve. Okay, so we're told it's on the curve. I'm going to pick three different points here and show you that the same principle works for any point on the curve. Okay, so I'm going to take this point here. I'm going to call this point P. I want to construct a tangent to the ellipse that passes through the point P. So basically, I know a tangent is a line that touches the ellipse at one point. I want that to touch the ellipse at this point P. So basically, I want some sort of a line that's coming along and going to be touching the ellipse at this point, at the point P only. Now, so how do we do this? With the majority of things majority of what we do with the ellipse, the first thing we nearly always have to find is our focal points. Okay, so from last week we know that the focal points is half the width of the major axis swung from the top or bottom of the minor axis. Okay, and the two focal points always lie on the major axis. Okay, so we see it doesn't make a difference if we swing it from top or bottom. It's going to be the same. It's going to be the same thing. Okay. So now these are my two focal points. I'm going to call them F1 and F2. Okay, it doesn't make a difference which one you call F1 or F2. Now, so having a look at this here, what are they doing? Okay, so we're told that the first thing is determine the focal points, which we've done. Now we want to join P to F1 and F2 respectively. Okay, so where's P? So this is P. We want to join a line to F1 and F2. Okay. Oh, there is some blue. Okay, so this is what we have now. Now, the second part, extend F2P to E. Okay, so where's F2P? So this is the line F2P. Okay, so extend it out to E. So I just want to basically extend that line out. Okay, the next part, okay, the bisector of this angle is required tangent. Okay, and I can also, now, so this line, this angle here, so the angle, I'm going to call this one E. So the angle F1PE, okay, so angle F1PE. Okay, I need to bisect this angle in order to find my tangent. Now, why am I bisecting this angle? Okay, why am I picking this one, and why aren't I bisecting, for example, this angle here? Okay, well, I know if I bisect this angle, so the angle F1P F2, for example, the bisecting line of that angle is going to run something like this here. Okay, now if that bisecting line, that's going to touch the ellipse at 1 point and 2 points. So I know it can't be a tangent because it's touching 2 points. I know a tangent only touches an ellipse at 1 point. Okay, so I'm going to go ahead and bisect this angle. Now to bisect an angle, just to go through it again, I'm going to put the point of my compass on the point on the vertex of the angle. In this case, it's point P. Okay, I'm picking a distance of my compass. It doesn't necessarily make a difference what size I pick, and I'm going to swing an arc on both arms of the angle. Okay, like this. So I'm after getting this point here and this point. From these 2 points again, I'm going to come from here. I can change the width of my compass if I want here now. Okay, and I'm going to swing an arc from there and from there. Okay, so I'm getting this point here now. Now, when I bisect that line, that angle now, so I'm going to join this back to the vertex P. That line I'm after drawing in here now is going to be my tangent. Okay, how do I know? Because it's only touching the ellipse at 1 point, that point P. And that point P is also going to be known as my point of contact. Okay, now finally on these, what we're looking at is asked us to find the tangent and the normal. Okay, so what did we say the normal was? Okay, so looking back here, we said that the tangent, okay, the normal was a line that was perpendicular to the tangent from the point of contact. Okay, so what have we got here? So we have the tangent. Okay, yes. We have the point of contact. Yes. Now I know that this that the normal is at 90 degrees to the tangent from the point of contact. So if I get my sliding set squares and line them up, okay, bring this line from the point of contact, and now this line I'm after drawing in here is going to be known as my normal. Okay, it's at 90 degrees, okay, or it's perpendicular to my tangent from the point of contact. Now, also what I could have done to get the normal, if any had spotted this, was if I bisected the line angle F1P F2, it also would have gave me the normal. Okay, it also would have gave me the normal. So just to show you. Okay, and we see the bisector of that angle also gave me the normal. Okay, so the points that we're joining on the ellipse, when we extend the focal points to the point of contact, extend it out, same from the other focal point, we're left with 2 different angles. Okay, so we're left with an angle in here, and we're also left with an angle in here. Okay, depending which angle I bisect will determine whether I find my tangent or my my normal. Okay, if I bisect this bottom angle, okay, and I see that the bisecting line is touching the ellipse at 2 points, okay, I know it cannot be my tangent because my tangent only touches the ellipse at 1 point. So then that means I'm after finding the normal. I know my tangent is always 90 degrees or perpendicular to the normal at the point of contact. So in order to find that, I'm either going to bisect the other angle, or what I can do is I can draw a line perpendicular to the normal from the point of contact, and that's going to get me the tangent. Okay, now this principle works for any other point on the curve. Okay, no matter where it is, it's the exact same thing. So let's have a look. Now, so I'm after drawing this this here. Okay, here is my 2 focal points, and here's my tangent. Okay, we see no matter where I bring this around, okay, I'll draw on the normal as well. Okay, so normal, and I'm going to leave we know they're perpendicular, and I'll put this as infinite length. Okay, now, so this is my tangent here because it's touching the ellipse at one point. This is the normal. Okay, watch now. No matter where I bring this around on my ellipse, the normal is always perpendicular to the tangent. It's always at 90 degrees to the tangent. Okay, so no matter where I bring it, let it be down the bottom or around. Okay, we see that to find the normal, it's always, no matter where it is, it's going to be the bisecting. It's going to be the bisector of the angle between the focal point on the curve, and back to the other focal point. So look, we see it here. No matter how small it gets, it's the same principle. If it's on the top, okay, no matter where it is, it's that principle the whole way along. And the same to get the tangent. It's going to be the bisector of the extended line out. Okay. So from that there, lads, you should be able to solve the question on page 1, or question 1 on page 113. So I'm just going to walk through it quickly. The figure below shows a design based on a fish. The curve is based on an ellipse with a major axis of 140, which we're told, and a minor axis of 90. Okay, so from there we can draw in the major circle and the minor circle and construct the ellipse. That's fine. Now, so we're not told F is one of the focal points of the curve. Okay. And the line AB is a tangent to the ellipse at the point A. Draw the given figures showing all construction lines. Okay, well we know if this F is one focal point on the curve, or one focal point of the ellipse, you are also going to have to find the other focal point on the ellipse in order to find the tangent. Once you find both focal points, I know that the ellipse, or it's a tangent to ellipse at the point A, which is this point here. You're going to join the focal point to point A back to the other focal point. Once you do that, you're going to bisect the angle, and this will get you the line, the angle AB. Okay, and then we know where that tangent finishes. It's just a straight line up from the top of the ellipse to where it intersects that tangent. That will get you point B, and you should be able to complete that question.